So we're going to go over section 11.3, the ellipse. The picture of the ellipse is right in front of your face. But what you need to know are all the terminologies that's listed there. So let's just go over this. So we have vertex and focus, co-vertex, center, major axis, and minor axis. The important thing that you need to know is that vertex and focus, they both lie on the major axis. The major axis is the long axis. There are two types of an ellipse. The first equation is the squash down ellipse, and the second equation is for the tall ellipse. And again, don't worry about memorizing it because I will give you this chart as well when you take your exam. Let's do some examples. Example 1, find an equation of an ellipse with focus at -4, 0, vertices at ±5, 0, and graph. Since you're going to be given the formula sheet, all you have to do is to pick and choose which equation that you're going to have to use. So what you need to find out first is which axis is going to be your major axis. And what determines that is where the vertices in focus are going to be located. So let's just give a rough sketch. Let's plot the focus. Focus is going to be at -4, 0. 1, 2, 3, 4. Whoops. What the heck just happened? 1, 2, 3, 4. And the vertices are at ±5, 0. So this will be -5, 0. 1, 2, 3, 4, 5. So this will be 5, 0. So it looks like both of our vertices and foci are going to lie on the x-axis in this case. Let me just jot down the other focus. And let's write down some information. So I'm going to say major axis is parallel to the x-axis. In fact, it is the x-axis in this case. So that implies that what we're going to get is the flat squash down ellipse. Okay, so with that said, which equation do we need to pick? Use equation 1. Okay, so that is, let me just write that out. X minus h squared over a squared. And then plus y minus k squared over b squared equals to 1. And the important thing is that A is always going to be greater than B for the equations of an ellipse. Given all that information, I think we can determine the center. So center is clearly going to be at 0, 0. Let me write that out. But this is denoted by h, k. All right, now since the vertices are given by ±5, 0. But look at the formula sheet. Formula says this is going to be h ±a, k. So since h is 0, let me just write that out, sorry. So h is 0, k is 0. Keep that in mind. All right, so since h is 0, so ±a better equal to ±5. So that implies that a must be 5. Let me just box all the important information here. Now the foci. We're given foci as well. Foci are ±4, 0. But if you look at the formula sheet, let me see, let me erase that. All right, if you look at the formula sheet, what does it say? Is it h plus or minus c comma k. But we already know that h is 0, so that implies that c must be 4. Alright, now all we need is the value of b. So how do you do that? Is to use this equation, b squared equals a squared minus the c squared. Alright, so this implies that we're gonna have b squared equals 5 squared and then minus 4 squared. 4 squared. Which is 9. So that implies that our b is going to be 3. So I think we're now ready to write the equation of that ellipse. So let's do this. So we're gonna have x minus 0 squared over a squared. That will be 25. And then plus y minus 0 squared over b squared, which is 9, equals to 1. Let's just clean it up a little bit. So here our equation is going to be x squared over 25 plus y squared over 9 equals to 1. Ta-da! Alright, so that is an equation of an ellipse, but now we're going to have to determine the co vertices. Before we do that, I want you to notice something. So notice that 25 was what? 5 squared, right? And then 9 was 3 squared. So notice the distance from the center to one of the vertex. So the distance from, I don't know if you can see this, distance from here to here is 5. Here to here is 5. That's precisely what's going to happen. So what goes along the minor axis, you're gonna have to go from the center up 3 and down 3. So you're gonna go 1, 2, 3, and then I'm gonna plot the dot. And 1, 2, 3, and you're gonna plot the dot. So that these 2 points are the co vertices. Therefore, co vertices are going to be at 0, 3 and 0, -3. Alright, now let's draw the final graph. Please pretend that this is an ellipse. And here we go. Let's do another example. Find an equation of an ellipse with foci at 0, plus or minus 2, and the length of the major axis is 8. Okay, so now let's just jot down and see what we got going on here. So we have a foci at 0, plus or minus 2, so alright, now since both foci, they lie on the y-axis, so that means that we're gonna have a long ellipse, which means that our major axis is going to be the y-axis. Sorry, I meant to say tall ellipse, not the long ellipse. Anyways, we know that the length of the major axis is 8. So that means that from the center, you're gonna have to go up 4 and down 4. So let me just jot down the center. As we can tell, our center is going to be at 0, 0. And we're going to have to go 4 units above. That's where the vertex is going to be. So that's our first vertex, which is 0, 4. And down 4. Okay, so now let's jot down other information. So the major axis is parallel to the y-axis. Well, in fact, it is the y-axis. So that implies that we're going to have to use equation number 2, which is x minus h squared and then plus y minus k squared over, this one's going to be b squared, and then a squared equals to 1. Again, a is always going to be bigger than b for the ellipse. Now we know that the center is 0, 0, so which is going to be our h, k. So we got h is 0, k is 0. Next one, our foci. The formula is what? H, k plus or minus c. But since h and k's are both 0, so you're going to have 0, 0 plus or minus c, but our foci is 0, plus or minus 2. So that implies that our value of c is going to be 2. Let's go with the vertices. The formula is h, k plus or minus a. But h is 0, k is 0 plus or minus a. But we already know that our vertices are going to be at 0, plus or minus 4. So that implies that the value of a is 4. Now what else do we need? B. Alright, so let's go with b squared equals a squared minus c squared. So which is 4 squared minus 2 squared, which is 12. So that implies that our value of b is going to be square root of 12. Always simplify. So our b is what? 2 root 3. Which is approximately, is it 3.5, I think? Alright, I'm just putting the decimal values because I need to plot the points. Now let's write the equation. So therefore, our equation is going to be x minus 0 squared over 12, and then plus y minus 0 squared over 16 equals to 1. Clean it up. Alright, so this is going to be our equation for the ellipse. Now let's go with the co vertices. Okay, now to find the co vertices, what we need to do is from the center, you're going to have to go, approximately 3.5 units to the right and the left. So let me just plot that point. 1, 2, 3, maybe like right here. Okay, so I'm just gonna, is that 3.5? 1, 2, 3.5-ish? Okay, perfect. So let me label co-vertices 2 root 3, 0, and then negative 2 root 3, 0. Let me write down the answer here. And this is my CV means co-vertices. And I think we're ready to finally draw the graph. Oh dear Lord. Okay, so that's supposed to be an ellipse. Let's just do another example. Example 3, find the equation in standard form and find the center, foci, vertices, and graph that equation. So first, it looks like we're going to have to complete the square, so let's get started on this one. So let me just separate x from the y. So let me just go with 4 times. I'm going to factor the 4 out. Just going to leave a little room because I need to add and subtract in there. So now let me just work on the x first. So I'm going to divide this number by 2. So you're going to have plus 1. What goes in here is 1 squared. So I'm going to have to add 1. That means I better subtract 1. And for the y, oh, I think I forgot to write 2y here. Sorry about that. Do the same thing, dividing by 2, you're going to have negative 1. What goes in here is negative 1 squared, so that's plus 1. Then you better subtract 1. Okay, so then the first 3 terms are going to become the perfect squared. So this is going to be x plus 1 squared minus 1. And then plus 3, and then y minus 1 minus 1 equals to 5. So now we need to distribute that 4 and a 3 into the equation. So we're going to get 4x plus 1 squared minus 4 plus 3y minus 1 minus 3 equals to 5. So now let's bring all the constant term on the other side. So then what we're going to get is what? 4x plus 1 squared plus 3y minus 1. Why did I forget the squared? Sorry. There we go. 2. And then what? So this is going to be 5 plus 4 plus 3, 12. Okay, now in order for you to make that perfect equation, we're going to have the right hand side has to be 1. So we need to divide it by 12. So it looks like our equation is going to be x plus 1 squared over 3, and then plus y minus 1 squared all over 4 equals to 1. Beautiful. So this is the equation in standard form. Now when you look at the formula sheet for the ellipse, your a is always going to be greater than b. So in this case, do you notice that of course 4 is bigger than 3? So our a is going to be the square root of 4. So here, our a is going to be 2. And then, same thing here, our b is going to be the square root of 3. Now, since the denominator on the variable y is bigger, we're going to have to use the formula for equation 2. So let me just write that. So let's follow the formula. So center is h comma k. So in this case, what do we get? Negative 1 comma 1. Next one is foci. H comma k plus or minus c. So in this case, what do we get? Negative 1 comma 1, and then plus or minus c, but we don't have c yet. So let's find the value of c. So if you look at the formula, c squared is a squared minus b squared. So that means c squared is 4 minus 3, which is 1. So looks like c is going to be 1. So here you're going to go 1 plus or minus 1. So which gives us negative 1 comma 2 and negative 1 comma 0. The vertices. Is it h comma k plus or minus a? So this is going to be negative 1 comma 1 plus or minus, what's a? 2. So it looks like we're going to have negative 1 comma 3 and negative 1 negative 1. Okay, so now let's start plotting points. So the center is at negative 1 comma 1. Oh, maybe the grid is too small. Sorry about that, guys. Foci are at negative 1 comma 2. Oh crap. I am gonna erase that. So I'm just gonna write it as C here just so that you can see it better. And negative 1 comma 2, that will be here. And then negative 1 comma 0. Oh, this is such a tight squeeze. All right, what else we got? Vertices. Vertices are negative 1 comma 3. And then negative 1, negative 1. Now, does it make sense? The major axis is going to be parallel to the y-axis, and the unit for A is 2. So from the center, are your vertices 2 units above the center and 2 units below the center. And yes, they are, because from center is here. So from here to here is 2. From here to here is 2. Now to get the co-vertices, the value of B is square root of 3. So that's what, approximately 1.7-ish, I think. So what we need to do is from the center, we're going to have to go right 1.7 units and to the left 1.7 units. So okay, I think that's pretty good. So now let's connect the dots and be done with this. Oh my goodness, this is such the smallest graph ever, but I hope you can follow this. But anyways, if you have any questions, please let me know.